Okay, everybody, welcome back. um, we left off before on page 61 to start page 62, and there was some code, uh, a three-dimensional array that we needed to code. I went ahead and kind of read through the code and already coded it. It was this paragraph that we were going to read next. I'm gonna read it. This is the code that we did before, and this is the that of that code, which before. Okay, so I'm gonna read what is next, the next lines, and I'll show you this code right here, which I coded ahead, and we'll move on through the book. So let's look at one more example that uses a multi-dimensional array. The following program creates a 3x4x5 three-dimensional array, and it then loads each element with the product of its indexes, or indices, so people read it. Finally, it displays these products. Okay, so, excuse me, here's the code. Okay, here's the code. Here's how where it prints the elements. And here's where it prints the spaces. And then this is the outcome of the code that we are to expect here on page 62. And as you will see, I have this outcome right here. I also discovered JShell for Java, and I started here to test snippets of code, which is amazing. Look at this. JShell verbose mode with the V right here. Code, and it's just so cool, so cool. It's almost like a Java IDE within the terminal, not just a text editor. Really nice stuff. And I have it open right there. So then I have the code here. As you can see, let me just open the code. But actually, I'll open the composing thing, and I will start texting here because it's gonna show the rest of the code. Oh. There it is. There's the rest of the code. So this is the code as I tested it. It has like this memory feature where it will remember the last thing that you typed, the whole thing, in the composer for iTerm 2. It's really cool because you can compose the whole code and then send it to Nano, and it'll already be there, and then you just gotta save it. Pretty cool stuff. You just gotta be careful to do it right, because otherwise you'll have to edit, and it's a pain in the ass. But basically this is it. Alright, this is it. And it's very cool. So that being said, there's the outcome. So let's go on to the next lesson, which is the alternative array declarations. 62, or the next point, I should say. Alternative array declaration syntax. There is a second form that may be used to declare an array. Type, variable name, and then the brackets. Here, the square brackets follow the array variable name and not the type specifier. For example, the following two declarations are equivalent, and then it gives you the equivalent declarations. Oh, excuse me. The computer's a little slow. I don't know why, but it sucks. Okay, and here's the original declaration. It's on the top. Int a1 brackets new int, and then the brackets with the number of indices that you, or the width of or length of the array. And then the bottom, the difference is that the type is what appends the brackets instead of the variable. So int brackets, and then the variable a2, and then new int 3. And then for three-dimensional arrays, there's a similar procedure here. And the first example is what we've been doing all this time. Basically, you say the type, and then you create a variable array, or an array variable. In this case, 2D1 with the two brackets for the two dimensions or dimensions of this array. And then the same thing, new character array with the two dimensions. And then on the bottom is the opposite, right? So you have the brackets added to the type and not the variable. So chart brackets 2D, new char, and then the brackets with the width of the array, of each dimension of the array. Pretty cool. Now, this alternative declaration form offers convenience when converting code from C to and C++ to Java. And it also lets you declare both array and non-array variables in a single declaration statement. Today, the alternative form of array declaration is less commonly used, but it is still important that you're familiar with it because both forms of array declaration are legal in Java. That's pretty cool. All right, let's see what's next. Okay, so introducing type inference with local variables. All right, come on. There we go. Oh. Okay, so introducing type inference with local variables. Let's bring it down a little bit. Okay. There we go. So not long ago, a new feature called local variable type inference was added to Java, or to the Java language, rather. Okay. To begin, let's review two important aspects of variables. First, all variables in Java. Let's make this a little smaller so that we can read the whole thing in the screen. Okay, let's see. This should be better. Yeah, it's somewhat better. Okay. Okay, to begin with, let's review two important aspects of variables. First, all variables in Java must be declared prior to their use. Second, a variable can be initialized with a value when it is declared. Okay. Furthermore, when a variable is initialized, the type of the initializer must be the same as or convertible to the declared type of the variable. Okay. Thus, in principle, it will not be necessary to specify an explicit type for an initialized variable because it could be inferred by the type of its initializer. Of course, in the past, such inference was not supported, and all variables required an explicit declared type, whether they were initialized or not. Today, that situation has changed. All right, and let's take a look. Okay. Okay, so beginning with JDK 10, it is now possible to let the compiler infer the type of local variable based on the type of its initializer, thus avoiding the need to explicitly specify the type. Local variables, what you're hearing is the mosquito destroyer. This thing, I need it. Local variable type inference offers a number of advantages. For example, it can streamline code by eliminating the need to redundantly specify a variable's type when it can be inferred from its initializer. It can simplify declarations in cases in which the type name is quite lengthy, such as can be the case with some class names. It can also be helpful when a type is difficult to discern or cannot be denoted. An example of a type that cannot be denoted is a type of an anonymous class discussed in chapter 25. Very nice. So that's a little further ahead. Furthermore, local variable type inference has become a common part of the contemporary programming environment. Its inclusion in Java helps keep Java up to date with evolving trends in language design. To support local variable type inference, the context sensitive keyword var was added. To use local variable type inference, the variable must be declared with var as the type name, and it must include an initializer. For example, in the past, you could declare a local double variable called average, AVG, that is initialized with the value 10, as shown here. Okay, so let's just scroll down a little bit. Using type inference, this declaration can now also be written like this. In both cases, average will be of type double. In the first case, its type is explicitly specified. In the second, its type is inferred as double because the initializer 10.0 is of type double. Okay, so let's just scroll up a little bit. Okay. And actually, this is a really cool brief opportunity to show how this thing works. I'll show you. Java shell. So we can do AVG, right? Equal the computer just kind of froze. What the heck just happened here? Okay. Okay. Okay, and it says that it's a type double. You see in JShell. JShell already knows because it used type inference. I just put var. Okay, which this will be the same as if I did this double VG. Let's call it 1 or 2. Type 11.1. Okay, and it will know. I don't have to put the column there because JShell actually knows to infer that as well. JShell is really cool. Like a very specific, very simple, straight to the point Java editor. It's amazing. Okay, so you can see there if I list okay, excuse me, list, okay, it will tell me. So now I can also do vars, and it should say that, there we go, it tells me the type of variable that they both are. So as you can see, they were both inferred. Okay, isn't that cool? Yeah, so let's get back to here. Okay, so let me clear this so we can have space. Alright, now let's keep reading down here. Okay. As mentioned, var is context sensitive. When it is used as a type name in the context of a local variable declaration, it tells the compiler to use type inference to determine the type of the variable being declared based on the type of the initializer. Thus, in a local variable declaration, var is a placeholder for the actual inferred type. However, when used in most other places, var is simply a user-defined identifier with no special meaning. For example, the following declaration is still valid. Let's see what that is. Okay. Int var1. In this case, var is simply a user-defined identifier. Okay, so it's a reserved keyword, but it's a context sensitive reserved keyword. So basically can be used outside of the context that it's meant to be used as a keyword, and it's still valid. That's pretty cool. Okay. In this case, there we go. Okay, I got to just do something quickly here. And it is, there we go. That should be fine. Okay. I don't know why we don't see everything. We should be able to see everything. I don't know why it's doing that. I have to check. Well, I'll check that out later. I'll check that out later. Okay. So for now, in this case, the type is specified as int, and var is the name of the variable being declared. Even though it is context sensitive, there are a few places in which the use of var is illegal. It cannot be used as the name of a class. For example, the following program, as the name of the class, for example, the following program puts the preceding discussion into action. Let's take a look. Okay. Alright, so here is a class. It's called var demo. And we're going to type all of this because we don't want to run out of the timing. Okay, let me show the. Okay, let me show the view, the timestamps. Let me see if you. Let me take a look here. Something wrong here. Doesn't want to. Okay. Okay, let me see if I can show timestamps here too. Oh yeah, I can. I don't know why it's becoming larger and larger. Okay, so this is gonna help me determine how much time we have been doing this. Okay, so from 6:18. Okay. Let's see, 6:06. 6:18. Okay. Alright, and it is now 6:23, so 5 minutes. Okay. I think we've been actually running for like 15. I don't think the timing is right from when I start counting. So, but let's type in this class and then we'll complete the video so we don't go over 30 minutes. So yeah, we're gonna use the here to help us, the composer. And this way it's going to be a lot faster to code this class. Okay, so let me just bring this down here. And we're good. Okay. Okay, so first the command for the shell, which is nano, and then var demo.java. A simple demonstration of local variable type inference. Okay, and then class var demo. Let's be quick about this. To a public static void. Alright, excuse me. And let me just make this a little smaller. Okay, here we go. Public static void main. I have to be very careful to do this right, because otherwise that's going to all my mistakes will translate into nano, and I don't want that to happen. And then let's see. Okay. So a couple of comments here. Use. Okay. Cut up. There we go. Use type inference to determine the type of okay, variable named in this case double is inferred. Variable okay, Okay. Nope. Okay. Okay. Plus G. Okay. And then following context var is not predefined identifier. A predefined. It's one of the advantages of using the composer that you could just do this. It is simply user variable name. Okay. Int var1. Value of var. I need to put another. Okay, let's fix that. There we go. And I think we'll be able to close that code. Okay. In the following sequence, var is used as both the type of the declaration and as a variable name in the initializer. Oh, that's interesting. Alright, so var k equals negative var. Also, it's using the previously given value of int var equals 1 to say that k is var minus 1, so 1 minus is negative 1 basically. K is negative 1. So var is going to infer that this is an integer or something along those lines. If I remember correctly, the shorts and the bytes are promoted to integers, so that's probably what's going to happen. It's going to be assigned integer or assigned int to be more specific. Okay, so I value of k plus k. Oh, that is really interesting. Okay, so now 1, 2, 3, 4. We close the main, we close the class, and I think we're good to go. So now we just, excuse me, copy this whole thing just in case, although I don't think we'll need to. And now we push it to the nano. Oh, what happened there? Oh, again, for some reason, this is what happens, mate. Okay, so now I go terminal Java. Okay, and I open the composer. Now we're in terminal Java. Oh, Jesus. Oh, I meant to do this here. Okay, so now, here we go. There we go. Much better. I don't know why it keeps doing that. Okay. So now we save it because we already wrote it. Now we var demo.java, compile it. Hopefully no mistakes were done. No mistakes were done. Okay, and we run it. And there it is. Value of avg is 10, value of var is 1, value of k is -1. Okay, pretty cool. Pretty cool. Pretty cool. Okay, this is interesting. All right, and finally, let's just try something here. For okay, so we have right there, right? So now let's do. I think it's int, right? Oh my God, what happened? I just closed the other. I just closed a window accidentally, and I don't know how to reopen it here. Well, that really sucks. Okay, so int var equals 1. Okay. Let's say replace with int. Okay, so now int var equals what should we say? 0. Okay, and now var k equals negative . Okay, so var k equals -I. There you go. All right, so let's pause it right here because I lost the session. I gotta open it anyway, and then we'll keep reading. Thanks for accompanying me. I messed that up. All right, peace. Thank you.